Today we are going to prove the lemma 3 of Kleene's theorem, and lemma 3 says that every language that can be defined by a regular expression can also be defined by a finite automata. So in other words, you can say if you have a regular expression, you can always convert that regular expression into a finite automata, right? So we can prove this theorem by constructive algorithm, and for that we have these 4 steps. The first step is, it is a fact that there is an FA that accepts only the empty word null operator, or an FA that accepts only single letter. So it is a simple thing that for a single letter you can always draw an FA. Like if you want to accept A, simply there is an FA that accepts A. Similarly, you can draw an FA for null as well. So this is, the simple thing that you start with, that you can draw an FA for null and for a single letter. So if you agree on this, that you can draw an FA for a single letter or null, then this is another claim that you can add 2 FAs. Like there is an FA for R1 language, another FA for R2 language, then you can have an FA for R1 plus R2. So, and the third thing is, if you have an FA for R1 and R2, then you can have an FA for concatenation R1 R2. And similarly, the fourth step is, if you have an FA for R language, then you can have FA for R Kleene star as well. So to prove this theorem, we have to prove all these things one by one. So by these 4 steps, you can say that you can always draw an FA for any given regular expression. Let's see an example. Let's say you have to draw an FA for this. So using the first rule, you can draw an FA for single letters. You can draw an FA for A and for B. So let's say this is R1 and R2. So next, if you can draw FA for these 2 letters, then according to rule, so rule 2 was R1 plus R2, rule 3 was concatenation, and rule 4 was Kleene star. So using rule 2, using rule 3, you can have this concatenation AA and AB. So, and you made this AA from 1 and double B from here, and then using rule 2 of sum, you made this one. Again using rule 2, this one. Then using rule 4, Kleene star. And so we have all the basic pieces of this regular expression. This. Now we use the rule 3 to concatenate. So I concatenate this part first, then the whole. So by this theorem, you can always draw an FA for a regular expression. Now we have to prove all these steps one by one. The first step is that you can always draw an FA for null and a single letter. So here, this is an FA for null, and if the starting state is also the final state, it means your FA can accept null. So it can accept null. So if you give any other letter, you will end up on this state, and this is the reject state. Only null is accepted. Similarly, this is an FA that accepts only single letter X. This is the starting state. After getting a single letter, you reach here. And for any other letter on the starting state or on the final state, you end up on this sync state or reject state. So we have proved that there are the FAs exist for empty letter and single letter. Now we have to prove the rule number 2 that says that you can add two FAs. So for that, stay tuned. In the next video we will prove that you can draw an FA for that is the sum of two FAs.